excellence, quality, science. These are just a few of the words that have been applied to the illustrious research career of James Mickens. In the span of a few years, James has made deep, fundamental, and amazing contributions to various areas of computer science and life. Widely acknowledged as one of the greatest scholars of his generation, James ran out of storage space for his awards in 1992. Especially remarkable because he hadn't even graduated from college yet. He subsequently purchased a large cave to act as a warehouse/fortress, from which he could defend himself during the inevitable robot war that was prophesied in the documentary movie, The Matrix. In his spare time, James enjoys life, liberty, and the pursuit of happiness, often, but not always, in that order, and usually, almost always, while listening to Black Sabbath. Ladies and gentlemen, please come to your rise and join me in welcoming to the stage James Tiberius Mickens. Okay, I was trying to figure out how to introduce James, and so I went onto his website, and I read, like, that's his bio. Like, that's the bio James has presented for himself. So that gives you a flavor right there, what James is all about. There are many tenured Harvard computer science professors who will take themselves so unseriously as that. Thank you, James. It's so great to have you. But in all seriousness, James is the tenured professor of Gordon McCabe Professor of Computer Science at Harvard. His research focuses on distributed systems such as large-scale services and ways to make them more secure. He was formerly with Microsoft, I'm going to talk about that a little bit. Earned his BS in computer science from Georgia Tech and his PhD in computer science from Michigan. James, welcome.
Thank you. Thank you. A great crowd already, I can tell. Very excited.
It's a hot crowd. Let's jump on in here and with some quick fire questions just to kind of get loose. Your first job, what was your first job?
I had a literal paper route that ended after my delivery rate for papers was below 30% for 7 days in a row.
I could do that.
They aim for about 45%, by the way,
And
in case you're not in the industry.
This was in the 90s, right?
Accurate, yes.
Right, so.
It's a crazy time back in the 90s.
Total decline.
Grunge music.
I saw that movie. What's one good thing that's happened to you this month?
I bought a new guitar, went down to Guitar Center, and I engaged in a little guitar duel, which people don't think are actually real. If you want to see ridiculous, toxic male masculinity, go to a Guitar Center. Because it's like all of these men who don't know how to play guitars, who are being upsold guitars that are vastly beyond their skill levels. And so you literally open the door to a Guitar Center, and just the world's worst music just assaults you from every direction. So there was like this 17-year-old kid there, and he was a little bit too big for his britches, and I just melted his face off with a solo.
Nice.
Yeah.
I like it. But, you know, you really can't play the guitar, even semi-seriously, without a Fender Stratocaster. I mean, there's no point if you don't have.
Fighting words. If anyone doesn't agree with what he just said, meet me in the parking lot of the Waffle House.
There you go.
After this talk. We'll settle it.
And so I didn't know that you're a musician, so serious guitar player?
I'd like to think so. As well as that dude that I melted his face, he thinks so.
Yeah, well, he knows what time it is. And what's one good thing, what's one thing that you wish you could be good at that you're not necessarily good at?
Humility.
On that note, all right, let's roll. So take us back, James. Let's start. Where were you born and raised?
So I was born in Atlanta, Georgia. So some of you may have heard of the 404 right there. Yeah, that's right. Yeah, represent. 404, exactly, about 25 minutes from the airport. Yeah, grew up drinking sweet tea, and basically my life expectancy would have been 5 years if I'd stayed down there. So I got to move out.
And so I'm always curious about people's upbringing, the central values that your parents gave you or that you claimed for yourself from the earliest age, and how do they carry forward today?
Well, I was very lucky that my parents both really encouraged education. And so I grew up in the South, and so a lot of my Southern relatives, they had these classic Southern lives, like my granddad, he was fighting in the military at age 5. He had 3 kids by the time he was 11, stuff like this. He was a proud man, right? But he said, I want you to go out there and do what I couldn't do. I want you to go to school, go to college. I want you to go to grad school. And so it was great. I always had that positive encouragement. Now, 1 year into my PhD, he said, what's taking so long? I had to explain to him, what research was. A lot of people don't get what research is. But he'd always say, can't you just read a book and figure out what you need to do? And I said, I'm actually trying to write that book. I'm trying to create that knowledge that is going to be a book or is going to be a Wikipedia article or something like that. And that's one of the reasons I got into research, because I like that idea of, at some points in the year, I might be the only person who knows something. I want to publish that eventually and tell people, but that to me is the excitement of research, that you actually get to, sort of squeeze these new facts out of the universe.
And the extended family, how many cousins, aunts, uncles out that way, Georgia or the
Well, in the South, that question doesn't have an accurate answer. There was a rotating cast of folks. In my direct family, it's my mom and dad and my sister. And then, I would hang out with, dozens of cousins and uncles and people claiming they were uncles who I don't think a DNA test would agree with that.
All right. And so so University of Michigan for graduate school.
That's right.
And then from there, straight to Microsoft?
That's right. So basically right after grad school, I went to work for Microsoft Research in Seattle, and I was in the distributed systems group. And so, I published, I did academic research there, but I also worked pretty closely with some of the product groups. So, Azure, the Windows group, doing distributed systems and OS research.
So way, way back, I was at a place called Rockwell Palo Alto Lab with Eric Horvitz, who you know from Microsoft, runs Microsoft Research. That's a big, and so I was in a think tank for a little bit, and I loved it. It was fun. You get to kind of just explore any old thing of interest. Not any old thing, but mostly, you're given a lot of free rein. Mm-hmm. And it's a very different kind of environment than a university. So I'm curious,
yes,
how did you decide to make a pretty significant leap from this fabulous playground that Microsoft was providing to the sort of higher stakes, more pressured situation at Harvard?
Yeah, well, it took some soul searching. It wasn't an easy decision. I think that one thing that is nice about doing industry research is that you always have to worry about money. I mean, that's just true in general. I always tell my students, wherever you go, learn how the money works in that organization, because that's going to affect your ability to do what you want to do. And so, roughly speaking, at Microsoft and a lot of the big tech companies, you ask for money. It's like a 0-1. There's not a whole lot of run around. It's not an elaborate courtship. The VP either says yes or no. Now, in academia, you have to write these grant applications. It's like writing a Victorian novel. I mean, there's just so many characters. You've got to justify this, that, and the other. It's got a 9-month turnaround time. And so you might think, why would I want to go to that situation where I have to constantly write these just angry novels that I don't want to write and nobody wants to read? I think for me, one of the big reasons was, mentoring and teaching. So I like that aspect of science, and I think that in general, there should be more people who are going out to the public and trying to evangelize computer science. I mean, right now it's all policymakers who are doing that. They're saying, get a STEM degree. And that's all fine and dandy, but where's the Neil deGrasse Tyson for, computer science or sort of tech writ large? And I want to be the sarcastic Neil deGrasse Tyson. That's my career goal.
You're well on a path.
Thank you, sir. Thank you, sir. So yes, I felt I miss teaching a lot. I miss sort of working with students. And I did want the freedom to be able to research stuff where, it might work out, it might not, but I didn't have sort of a VP telling me what to do. Even in a sort of wide-ranging industrial research lab, you do ultimately have to answer, to someone who can, give the thumbs up or a thumbs down. And you go to academia, there's the tenure system. You may not get tenure, you may get it. But other than that, you have a lot of freedom to, sort of make mistakes, try new things out. And I was really excited to do that too.
But beyond all the pesky writing of grants, there's also just the politics of the university. I'm wondering how that's treated you.
Yeah. And by the way, speaking of grants, I'm willing to marry a rich aristocrat so I don't have to write grants. So if any of you are a rich aristocrat or know of a rich aristocrat, or aristocrats plural, I'm very modern in that respect. So just let me know, because great writings for the birds.
Duly noted.
Yeah.
We know people. We know people who know people.
Yeah.
We'll hook you up.
Excellent. Yeah, sorry, go on a Zeppelin ride. It'll be great. That's how that stuff works. So yeah, the politics, I mean, like, it's like different type. It's just kind of like, wherever you go learn how the money works, wherever you go learn how the politics work. I mean, it's like different types of politics. So you go in industry, and like the reason that the politics there can be very sort of intense is that, it could be like a whole product line that's going to like live or die based on what you do. Like I remember I would go, as a young researcher, I would go talk to these product groups. And I was so full of confidence, just got my PhD. I'd go in there, and if you're a researcher, what do? Boxes and arrows. That's what you do. You give me a whiteboard, boxes and arrows. I could do that for hours, just not even anyone looking, just boxes and arrows. So I remember one time I went to talk to sort of like this seasoned person from the Windows org, right? And this dude, he was like the architect in the Matrix. He just knew everything, And so I came in there with my young man strength. Just finished like, drinking a Red Bull or whatever. And I'm like, hey, you want to hear my cool research idea? It's going to be amazing. It's going to just blow your mind. And so he responded, of course, with like old person strength. He barely even moved from his keyboard. He's like, yeah, tell me your fancy idea. And I was like, don't mind if I do. So then I took his marker from him. I was like, I took it from him. I said, look, imagine a world where, like I literally said that. Don't ever say that, by the way. Like, imagine a world where, and then I went up, I drew all this stuff. And he just sat there, and he was just like, and then you probably, So I was so happy because I thought it went well. Now, one thing you learn as you get older, if you have a conversation where the other person's totally silent the whole time, that's not a good conversation. They're just like laying in wait to punish you, right? So I went through like this 45-minute explanation, and in the end he says, he points to the whiteboard, and he says, so great boxes and arrows, and already I'm starting to feel uncomfortable. That didn't sound like a compliment. He said, great boxes and arrows. He says, but there are two things I don't see there, customers and money. And I'm like, yeah, because, oh no. And it was like one of those like first date experiences where you knew immediately we're not going to be seeing each other, are we? This was the first and last time that this pairing is ever going to be up there, And like so that's the politics there. Where's the money come from? Where's the head count come from? In academics, like tenure cases are very fraught with politics. Like, do you think that someone's done enough for whatever that means to get tenure? Interacting with students can be very fraught with peril too. Students sometimes bring their own.
Especially.
Oh yeah, totally. And like the students, they have their own ideas sometimes about like what they should be taught. Like at Georgia Tech's like a Southern engineering school. There was no back and forth about like what students wanted to be taught. No, the Georgia Tech professors, they had tablets from Moses, and this is just tablets we've been using for years. And you just don't question that, Harvard's a little bit different, students push back a little bit more. That's okay. I mean, I tell them about the whole face melting thing with the student that usually shuts people down.
Let's switch gears. So how many people here, with show of hands, how many people here have bought Bitcoin, crypto, some kind of cryptocurrency in the last couple of years? All right, wow. How many, keep your hands up if you're net positive? Well, all right. And net negative? That's honest. Okay, so James, I know you're a huge Bitcoin crypto booster.
Yeah, totally. I'll be selling some Mickens coin. Yeah.
Time named you like the lead propagandist of the entire crypto movement, something like this.
Basically.
Yeah, right?
Yeah.
Why do you love it so much?
Just in case people don't see the sarcasm, I hate it with a burning passion. I memorized everyone who raised their hands, positive or negative. You're all in big trouble. You're getting kicked out of Superset. Sorry to be the bearer of bad news.
By the way, 0 Bitcoin over here. And I saw those raised hands too.
That's right. Exactly. These are why we're in the corner offices. Do you see? Because we avoid that stuff. So why do I dislike it? Well, thank you for asking. So I'll give you sort of like the short version of this. So when I was in grad school, I did my dissertation on distributed systems. And so, like, in fact, I did my dissertation on those peer-to-peer systems that were so popular in sort of like, the 2000 to 2008 era. So I was initially a huge sort of evangelist of anything decentralized, anything that's going to take power from the man. You know, it seems like such a great idea. It's just take it just for us.
Word.
You know, exactly. See, that's right. We're just dropping some flowetry here. That's what they call it in New York. I've been there several times. I'm very cosmopolitan. So I was like, this is great. So we're going to have this really decentralized thing. And like, it made sense for a bunch of different reasons. Maybe it gives users more control over their data. Maybe it allows us to be more resilient to faults, you know, so on and so forth. But like a big outcome of a lot of the distributed systems research from, let's say, 2000 to 2008 is that totally decentralized systems are horrendous for many reasons. And like a classic example is like, you know, let's say that I want to use, okay, so all of us decide to join a peer-to-peer system. And we're going to have a peer-to-peer backup system, okay? So the idea is like, I'm going to store some of my data on you, you're going to store some of your data on me, and then it's like, that's great, right? Because if one of our computers goes down, you know, it's still replicated somewhere else. Well, here's the thing. Like, you know, you have those relatives or friends whose computers never work and are just riddled with viruses? That's who you're entrusting your data to, right? That's a problem, right? An advantage of centralized administration is that, like, you know, Amazon or Microsoft, whoever, pays professionals who have pagers. Can you even believe such a thing? That people still exist who have pagers, right? That's horrendous. There are people who will miss like important moments in their children's history to make sure that your Lambda function is still running. How great / horrifying is that? Okay, so now contrast that to, like, let's just say my uncle. I have many uncles, that doesn't narrow it down. So my uncle, right? I call him up and regularly I ask him to open up the Task Explorer on Windows. Regularly, his CPU utilization is 100%. He's not mining crypto coins. He's not even has any visibly open applications. Okay? So, like, let's call him the CSI people, right? Like, we understand he's been deep compromised, as we say in the field. So, like, as it turned out, people did all these studies, and they'd show, like, if you look at the availability of hosts in, like, a truly peer-to-peer distributed system, it's very low, right? It also follows diurnal patterns. You know, people will turn their computer on during the daytime in their time zone and then turn it off afterwards. Well, what if my computer crashes and all my replicas are in, like, some different time zone? Oh, well, I asked for it. Right? I brought this ruin on myself. And that's really what the motto for cryptocurrency should be, isn't it? I brought this ruin on myself, right? And it's like, if you look at a lot of these other cryptocurrencies, I'll end the rant very shortly, but it just brings me so much psychological pleasure. So if you look at a lot of these cryptocurrencies, they just replicate these very basic economics mistakes that, like, if you've taken an Act 10 class, you would know this is a bad idea. Right? So as a classic example, think about like stable coins. You know, so the idea here is like, oh, Bitcoin's too volatile. So what we're going to do is we're going to peg the crypto coin to some stable asset of value. Well, anyone who's taken like a basic economics class knows that, first of all, you're importing the monetary policy of the peg. This has been known since like time immemorial, right? It's like this happens in countries that peg to the dollar, for example. Right. Whatever the Federal Reserve's monetary policy is, that's your policy. So then like these crypto people get surprised by this. It's like, what's going on here? It's like, you can't read. That's what's going on. Like, this is totally your fault. I'm glad you're going to be poor. And so, like, another problem, too, quote me, I literally don't care. These people are so silly. And, like, another problem is that, like, you may have heard, like, TerraCoin, you know? They pegged their stable coin to another thing that wasn't stable. And then, like, that other thing, and then it all went away. Right. It just, all those coins live in heaven now. You know? And, like, let me tell you what you can't retire on. Coins that live in heaven. So it's just a really bad idea. And we can talk about it later, but yeah, I don't like them.
See, so is the current meltdown, from your vantage point, this is probably a leading question and too easy, but is it evidence of markets and otherwise intelligent people finally coming to their senses? Or, because you still have the crypto enthusiasts out there who say, hey, whoa, we just need a little time. Every new technology takes a little bit of time. And I'm always fascinated by that because it's been a decade, right? When SQL or HTML came out, hey, whoa. Decade's much too soon to know if this is going to work, right? So, but I mean, which way do you think it falls right now?
It's totally that. I mean, we've been waiting for like the killer crypto application for, like about 10, 12 years, and it hasn't come up yet. And like so far, crypto's only proven to be a good way to separate fools from their money. Now, as it turns out, like, it doesn't even innovate. Like, that wasn't a hard problem. You know, like scammers weren't sitting around saying like, I just wish there were a way to steal money from dumb people. You know, like that just happened since we crawled out of the savannah. So yes, I think what ends up happening is that you just have these cycles like any speculative asset. You know, and so basically what happened, you know, a lot of the crypto people said, oh, they're going to act as a store of value. Oops. Right. Would you like to retract those tweets? Because what happened as soon as there is volatility in the standard markets, people drop crypto like a rock and then they go into dollars. You know, they go into euros.
So I think this Fireside Chat is going pretty well, James, so far.
I'm feeling that vibe too.
But I'm wondering, there's just so much hemming and hawing from you on these topics. I wonder if you could just say it more, say what you really think as we move forward.
I try to be coy.
Yeah, you're very coquettish. So with our computer science hats on now, and for the builders in the room, what are good organizing principles for us to think about the relative strengths and weaknesses of decentralized versus centralized methods, right? Because maybe there's a kernel of truth or a useful lesson learned in here somewhere. How should we be thinking about those general questions?
Well, I think that's a very good question. I think that the first thing to do is to basically do something that's very boring but very important, like a requirements analysis. So, you know, a lot of the times when people come to me and they say, oh, I need a blockchain, I need some hyper decentralized thing, you know, I'll literally say, okay, so what are you looking for? And I'll walk them through like this literal exercise. Because a lot of times they'll say, I want a database. Like the more reasonable people say, I want a distributed database, it's highly available, stuff like that. As well, you should want that. Everyone should have that in the 21st century. So I say, okay, so just to be clear, why can't you use an Excel spreadsheet on a single machine? I have to give them something because I'm about to annihilate them, right? So I say, why couldn't you just literally just have an intern have an Excel spreadsheet that they are the manager of? And they say, oh, for shame, professor, that would never work because, you know, what if that intern gets, you know, mono or whatever? I'm like, okay, yeah, so that makes sense. So I'm like, okay, so why not have like a Google spreadsheet? Okay, online, Google Docs, you know, so now it's distributed. Now it's backed up by, professionally maintained servers. And then sometimes they'll say, and by the way, like some people tap out at that point. They're like, oh, provocative. You know, like, that's it. Like, and a good day to you too. It's like in 10% of the cases, like that's it, right? And then sometimes they'll say things like, oh, you know, we want to be able to run SQL queries, let's say, or do like have a better programmatic sort of interface to it. Right. And then I'll say, okay, so why not use a database as a service? You know, that, you know, Amazon or Microsoft has, or just use one of these open source things, you know, and just use one of those. And like, that's essentially where everyone stops, yeah. You know, because like most of the people that I talk to, you know, they want to do like, you know, business to consumer stuffs, and they can't tolerate the failure modes that you would have in many of these decentralized systems. Right. You know, you need, for example, at a minimum, in almost every reasonable case I've heard of, at least centralized, logically centralized authentication and sort of like user registration. Because if you can't do that, if you literally have no idea who's showing up to your service, and you want to provide, you know, auditing, you know, to like the government or someone else like that, you're in a big world of hurt if you can't do those things, right. You know? And like one of the things that I think people don't fully understand about like pseudo-anonymous or truly anonymous systems is that like one thing that makes our nation great, and this is going to sound very controversial, is I can sue people when they're bad to me, you know? And like that sounds like mean and we all hate lawyers and blah, blah, blah. But like fundamentally speaking, that separates us from chaos. Right? Because I engage in a contract with you, and then like, you know, let's say one of us, you know, reneges, I talk to your lawyers, and then we let the legal system figure it out, right? So people seem to think implicitly, and that's what's so funny about it, implicitly, they want to live in a Mad Max world. Right. Implicitly, they want to live in a world where it's like, we'll just agree to do something. It's just written in the clouds, you know? And then like if one of us backs out, oh, well, that's what happens. I mean, oh, well. No great empire or civilization. Oh, well. That makes no sense whatsoever. So, yes, I think that people should just do requirements analysis and then see to what extent your application actually needs to be decentralized. Yeah. Sometimes it will need partial decentralization, but very rarely full.
No, I looked at my co-founder Vivek here because in a different way you were espousing Vivek's principle, which is at the beginning of those kinds of conversations like, hey, this is really cool, we should do it. what problem are you trying to solve, right? It's one of the themes.
Exactly. Yeah, and I mean that's like one reason why it's funny to like one funny thing about being a professor, like it gives you it's almost like being really old. Society gives you an excuse to be petty, to be very judgmental. I can't wait to be old and a professor. That's going to be just the Venn diagram.
Fire. That's going to be awesome.
Awesome. Yeah, it's like I hear this from, getting back to what you're saying, I hear this from startups all the time. So people come up to me, right? Like I, particularly, like I go to like the WeWorks, like those types of things, the prairie dog houses for humans, right? And so I go in there and these people come to me, hey, you want to hear my great start? I don't, actually. But like, of course, when they say that, that's a question statement. It doesn't actually end in a question mark. It has an uptone, but they're going to tell you anyway. So they tell me something, and they don't talk about the motivation. They don't talk about what problem they're solving, why they're doing it. They're basically just talking about what they're going to build, and that's a huge problem, because it's like we already have enough tech that sort of exists for its own sake. We should be using technology to further some, goal that makes, the public good better.
Hey, so let's switch gears here and take one of my favorite topics, which is privacy and security of data.
Sure.
So we're operating in a regime right now that, in my view, is really long on rules but short on tools. So speaking of lawyers and well-meaning policy regulators and GDPR and CCPA and so on, so we got a lot of documents, lots of rules, new regulations every month, frequently ambiguous or in conflict with pre-existing ones. I'm learning more about that in my job at Catch. So the question over here is, how do engineers in this room and elsewhere start to build systems that by design are compliant with security and privacy laws today, but also they can sort of gracefully absorb the inevitable shocks and surprises in the global regulatory regime that are coming for sure? Like, how do you get it both ways? How should we be thinking about that?
Yeah, it's an important and hard question. And I think that, at a high level, a lot of questions involving privacy and security, you're never going to be able to have like a perfect design methodology, but you can at least start thinking about these things early in the design process. I mean, that's sort of like the best advice that I have, because it's hard to sort of anticipate. I mean, the Europeans are very creative. These things they're coming up with, I mean, it's just amazing in 18 different languages. And so, like, you never want to be in the sort of game of like predicting what the French are going to complain about. But I think that what you can do, for example, is try to design architectures that make it easy, for example, to understand, who are your principals? What are the main objects that those principals are manipulating? Do you have, necessary logging infrastructure to track what's going on? So I think that those things, need to be baked in from the beginning. Because, once again, another problem I see with a lot of startups, they tell me this whole long-winded sort of story about what they're doing. And I'm like, so, for example, what is your a security breach plan? So, what happens if someone, breaks into a server, stuff like that? And they always kind of look at me, and they look at me silently as if they're trying to induce me to give them the answer. But like, I won't do it because I just love uncomfortable silences. So then we just get in this weird stare down, and then I don't know, then just the sun engulfs the earth. It's 35,000 years, whatever. So I think it's like really important to sort of think about those things from the get-go, and also to try to actually have teams that are interdisciplinary and like include like, for example, heaven forbid, lawyers in at least some of these meetings to sort of raise, red flags early before you just say like, here's our final product. Oops, we got to be compliant with GDPR. Let's annotate some stuff.
Right. Well, and as you know from your involvement with the Ethical Tech Project, that's exactly the approach we're trying to take. And by the way, I'm not a lawyer, and I probably share most people's skepticism. I mean, lawyers mean well. They're paid to argue, not necessarily paid to like solve the actual problem. But we need them at the table, right? We need the lawyers, the legal, the policy, the business people, and the engineers to try to figure this thing out. It is such a gnarly problem. Also, what I hear you saying, James, is you can't really staple it on post hoc. Right? Like,
that's right.
Oh shit, we didn't think about privacy. We should probably try to do something for, which is what we see all of our customers at Catch dealing with. It's gnarly, but the technical puzzles are so cool still, right? So it's important and it's gnarly, but increasingly solvable. Hey, I want to come back to the topic of money. So you have Black Sabbath on your bio.
Yep.
So I presume you've seen Spinal Tap.
Of course I've seen Spinal Tap. Yeah.
All right, then. So you remember from their Beatles phase, the early Beatles phase, with their little moppy haircuts before they went hard. You remember the song "Give Me Money"? Give me some money.
Give me some money.
There you go.
Yep.
Stop wasting my time.
Yep.
You know what I want. You know what I need, or maybe you don't. Do I have to come right out and tell it to you? Give me some money. So, engineers and money. Sometimes it's a fraught thing, and I think, and I heard you touching on this. I wanted to come back to it because, and speaking of coolness for coolness' sake in crypto and all of these kinds of things that glisten conceptually that good engineers want to chase down. But it's also difficult if they lose sight of that kind of grounding reality that you talked about, which is, wait a minute, there are these pesky people with called customers who sign contracts with us that give us money to put in a bank account, not a crypto account. So how do you engage engineers in that kind of dialogue? Because I think it's the times when I see engineers kind of getting caught in the ditch of, well, stop bothering me with your pedestrian money-making P&L shit, Chavez. I'm building tomorrow's technology today.
Yeah.
How do you change the conversation? How do you enroll them in a conversation about money?
I mean, you can just say, you're fired. That's always an option for you. And then also, I just want to note that I now discovered the title for my autobiography, "Glistening Conceptually." The James Mickens story. Exactly. Yeah.
At least I'm contributing something to this conversation.
You just
finally
got the forward, buddy. So I think that it's actually pretty hard. I mean, this is one thing that we see too, in the educational system, when we're trying to basically convince engineers to care about anything besides engineering. Because in a certain sense, I think a lot of us are drawn, even me personally, I always liked art and literature and stuff like that. But I also didn't, there was part of me that I didn't like the fact you could write your way out of a dilemma, in English class. You could always be well, and then Zeus showed up, and he's Zeus, so, whatever. You can't do that in engineering, right? At least in theory, you have, there are objectives, and then there are things that you solve, and that just felt very sort of fulfilling, 17-year-old me. But I think the thing that hopefully you learn as sort of you get older is that, all of these things that we build now as engineers, this is not like the 70s where we make some cool server that only 3 people know about, and it's fine if there's no security because who would break in? It's got to be Todd. He's the only other person who has access permissions. But it's now everything we build, it's a socio-technical system. It's not just the code and the data and stuff like that. It's how does it interact with customers? How does it interact with law? How does it interact with the environment? How many trees you have to burn down to create the electricity to power your data center. So I think that really that's a question of education, what you're talking about. How do we educate engineers, and how does that education sort of carry through, not just through high school or college or grad school, but even out in the field, once you've graduated. And I think for me, the way that I've seen this work the best, and this is generally good advice, I think you got to talk to people. In general, my best mentors, one common thing they all told me is you got to talk to people, because that's sometimes the only way that your awareness is going to be expanded. And in fact, when I went to Microsoft, the first year I had this tradition, I'd block out 2 hours in my calendar every Thursday, and I called it Donut Thursday. And I literally would not accept meeting requests during that time. And then I went around and I gave candy to people. Now, what was interesting is that most, maybe about half the people didn't take any candy. But it was an excuse to talk to people. It kind of de-escalated the tension, because I'd come in and say, "Oh, you want some candy?" I'd say, "Oh no, but what's going on? What are you thinking about? What are you working on?" And I came up with some really great sort of cross-pollination ideas, just going out there and talking to people, the legal people, not just researchers, HR folks, things like that, customers, who happen to be on site. So I think that really all engineers would benefit from talking to people across the org. And a lot of engineers maybe don't realize or don't take advantage of the fact that even at a quote-unquote tech company, there's a ton of people who are not devs. There's a ton of people who are not quote-unquote building stuff in the engineering sense. But these people are valuable. They have insights, and you should be listening to those people, because it's good for them, it's good for you.
Hey, I promise I'm not going to hog the mic the whole time here. We're going to be opening up for questions in a minute. But I know that you're thinking a lot, James, these days about trusted hardware.
Yes.
Let me say at the beginning, I'm a software guy. I was forced to take a circuits class 25 years ago. Hated it. So I don't really think about, I don't want to think about what's happening at the microprocessor level. I'm comfortable, at the level of, data in transit, data at rest, data getting crunched and analyzed in memory. There are these new CPU technologies that I know you're paying a lot of attention to from ARM and Intel and other places that seem to portend dramatic things for the processing of sensitive data. Can you give us a quick tutorial on what's cooking there, and what advice do you have for us? How do we get on the swivel and get ready for that? What should we be paying attention to? Does it change anything that we're doing today?
Right. Yeah. So I think this technology is super cool. I'll be selling pamphlets after the talk, $2 each. Okay. I only take 90% of the profit. So basically, here's the way that I look at it. Right. So the past 20 years, data center computing has been a big thing, and also smartphones have become a big thing. Right. So, let's talk about one of the challenges in data center computing. So classically, there's been this challenge in distributed systems, which is that I want to run my code on a remote machine that I don't administer, okay? And I do this because it's I don't have to worry about the hassle of making sure it's on all the time, so on and so forth. Sounds like an awesome deal. That's why so many people move to the cloud. But there is always this classic tension in distributed systems, which is how do I, as the tenant who wants to run something on that remote machine, how do I know that, for example, the AWS operators aren't inspecting my computation, aren't tampering with it in some way, aren't stealing my data, right? And so to a first approximation, for many years, people just said, oh, well, that's just sort of a fundamental trade-off. And if we discover, let's say, AWS doing that, we'll sue them. But there's no technical mechanism to back that up. Yep. Now, of course, some of you object. You say, but I know about crypto stuff. I mean, the real crypto, not the Bitcoin stuff, right? But so things like, multi-party computation, or things like differential privacy. Some things we've already heard, in some prior presentations at sort of this convening. So at a high level, what do those sort of crypto or math techniques allow you to do? Roughly speaking, they allow, let's say all three of us are in a computation. We want to contribute data, but we don't want to reveal it to the other people. Using some fancy math, we can sort of submit encrypted data. We can each compute over that encrypted data and then get a clear text result without revealing our individual data. Very roughly speaking, that's what multi-party computation is. We all work together to perform a computation, and then we see a clear text result without revealing some of the data. Now, the problem with this, apologies to the crypto people, they're very good people. I don't invite them to parties, but I should, right? So, but many of these techniques are very, very slow, and or they're not expressive enough to support systems code. So by systems code, I mean sort of stuff you traditionally write in C, C++, databases, web servers, things like that. The math just isn't a great fit for that. So it's a classic example. Let's even look at differential privacy, a technique that was discussed, I think, in the last session. Differential privacy, very roughly speaking, says, I've got a database that has a bunch of numbers in it. I want to be able to query those numbers and not reveal too much about any particular number there that belongs to any particular person. So we add some statistical noise to make that happen. Okay, that's great. But as it turns out, many important sort of systems you build at data center scale aren't just databases of numbers. How do I build a key value store that I can't add noise or else my system literally breaks? I can't add noise to a list of IP addresses, because if I add noise to it, then I'm just going to some server, center of the earth or whatever. Okay, so this is tension, right? The tension is I want to outsource stuff to the cloud, but unless I'm willing to sort of use these crypto techniques that might be not expressive enough or might be too slow, I have to reveal my state to the data center operator. So basically what Intel said, and some other hardware vendors, they said, okay, look, you as the tenant, you already have to trust right now the server hardware. So let's say AWS uses Intel CPUs. You already have to trust that Intel's not sort of putting in its CPU like a spy that's going to send data off. And right now, you're also trusting the rest of the software stack. Right. So the hypervisor, stuff like that. What if all you had to do is trust Intel? So what if Intel gave you the ability to essentially run a special type of process such that the hardware guaranteed that, let's say the memory pages in that process couldn't be examined even by the hypervisor or the OS? You might say, but how does that work? I sort of learned that the OS or the hypervisor has ultimate control. Well, only because the hardware allows it to. So in these new chips, right, like SGX Intel chips, you can create this thing called an enclave, which is basically like a process where the memory is off limits, even to the OS or the hypervisor. And furthermore, that memory is kept encrypted, right, in RAM. Why is that important? Physical possession attacks. So now, even if, Jeff Bezos, assuming he's not on Mars right now, even if Jeff Bezos, and let's assume he also has a double E degree. So Bezos on Earth, double E degree, right? And
I'm with you.
That's right. And he hates me in particular. So I'm running something on AWS. Even if he probes the memory bus with like double E tools, all he's going to see is just encrypted data going back and forth across the bus. Right. So this is a really neat technique, right? Because now, it dovetails with all this stuff like, HIPAA compliance and like GDPR and stuff like that. Because you can imagine a lot of hospitals, for example, want to outsource computation, but because of various laws, they can't do that and still satisfy those laws.
So this is kind of a mind roast for me. So in the same way, with GPU, I don't have to think. The chipset is making sparse matrix multiplication way faster, cooler, better, so that your AI applications hum. But you don't know how. It's happening at the chipset level. Is there a similar? Because when we talk about sensitive data, and back to privacy for a minute, it seems like there would have to be an abstraction by which I could say, in the context of GDPR, say, my name is Tom, you can use my age and location for targeting, but not for analytics. And then over time, the line changes on, well, actually age isn't a sensitive, we're not going to count that as sensitive data anymore. At the application level, I need to somehow specify something, it seems to me, about the data itself that the CPU, that Intel can't know anything about. How, and you're saying that it's not manifest or touchable through the OS or the hypervisor. Will engineers in this room experience and see and touch any of this, or will it just all be auto-magically handled at the CPU level?
So the way to think about it is that like this trusted hardware provides some helpful building blocks for sort of privacy by design software. But in and of itself, it is insufficient to provide, sort of an end-to-end picture. Like basically think of like the sort of like SGX style technologies. That's SGX, software guard extensions, X for extensions because it's awesome. Think of that as basically sort of mostly solving the problem of how do I trust that a computation running on a remote machine has not been tampered with by the physical owner and administrator of that machine. But like in terms of doing things like finer grained ACLs, like inside this sort of special computation, what's the granularity of data ownership or things like that?
Yeah,
that's still a software level issue.
Okay.
So Intel doesn't solve that with the CPU.
And actually, so if I can build on what Tom said, doesn't that make your application more complex now, because your application will have to manage that enclave and the data that you put into that enclave itself? So
the short answer is kind of yes. I mean, the reason is, but I don't think it's too onerous. I mean, the reason. So SGX, for example, one reason it's tricky. Oh, did you have a question?
No.
Oh, sorry, just hydrating. Yeah, mm-hmm. I'm just blowing your mind so much that you're just racked by thirst. So the model for SGX is that the OS and the hypervisor aren't trusted. Now, that's kind of crazy, right? Because like normally as like an application developer, we rely on that software to protect us from other applications. Okay, so with SGX, the hypervisor, the OS, otherwise known as like privileged software, it's not trusted. Okay, but so here's a crazy thing though. How do you do I/O? So like now your enclave, this SGX computation, wants to talk to the outside world. Now, how would you do that in a normal situation? You just get a regular process. You make what? System call, right? System call talks to the OS, sends it all out, right? But now we don't trust the OS. So how do we, how would we do I/O in this scenario? So this gets to your question about does application development become trickier? So basically what you have to do is before you request the OS to handle I/O, you have to encrypt it, you being the enclave code.
And actually, so when I said application, I meant applications that work, so B2B applications, which use a database. So in this example that you're giving, the database provider actually has to write a customized version, like Postgres, would have to write a customized version of Postgres that works on SGX.
Not necessarily. I mean, this is where we sort of get the devil's in the details, right? But like there are ways that you can use commodity databases to store encrypted data, and then you can basically run queries over that encrypted data in a way that like the Postgres engine wouldn't know what the clear text is.
Sure, but that's a software that's provided to you by the software that's running those queries and interpreting the data in parallel with whatever's happening in Postgres. It's not a hardware guarantee.
It's not SGX. That's right, and that's the layering that you'd want, by the way, right? And so just to be clear, like this is very important because like when you sometimes people interpret like SGX or Trust Zone, which is like ARM's roughly speaking variant of it, it's like, oh, this solves all the problems. No. Really, what those technologies are talking about are memory isolation for the process. They also provide this technique called attestations. I haven't mentioned that earlier. That's basically a way of saying, like, so let's say I'm AWS, you're a client of one of these secure services. You might not want to share sensitive data with me, the enclave, unless I prove to you somehow I'm actually running some verified version of something. So roughly speaking, attestation says the SGX hardware on this server is going to sign the hash of the code that's running here. Sends it back to you. You say, has it been signed by a valid SGX chip, so on and so forth. So yeah, so long story short, think of this stuff, I mean, sort of in the same way that we might think about like these cryptographic techniques, like, MPC, multi-party computation, stuff like that. They typically solve, certain parts of the end-to-end story, but you still have to think about application design.
More questions. Let's open it up. Yeah, Pankaj, let's get you a mic.
Thank you. So I have a question. First of all, thank you for this interesting conversation. And I'm going to talk about a topic that is dear to both you and me, which is crypto. But I'm going to spice it up with the topic of misinformation. So if you think about crypto, like it has spread like a wildfire. And there's a small group of experts, so-called experts, talking about a decentralized world, and where, it's all great. And then they're promoted by people like us who are techies, who are then spreading that information without knowing enough about it. As you said, most of the people here who raised hands, right, they are techies, right? And the second part is interesting because I before this talk, I watched your video, a small clip on YouTube. We are talking about nation states. Right? And actually, nation states are controlling this decentralized economy. Like I was just doing the research, 65% of the mining happens in China, right? So where is decentralization happening, and what's causing this? Like educated people are making statements which don't resonate with the training they have received. Like what's causing that?
Yeah, so a series of interesting questions. So first of all, like I think that if you look at different sort of crypto communities, the level of technical sophistication varies like by orders of magnitude, like actual powers of 10 magnitude. And so like for some, like take Ethereum, for example, right? Like if you look at their white papers, for example, like many of them are actually like legitimate distributed systems papers. Now, what they're going to do with the blockchain is real dumb. But from just sort of like a pure like theoretical distributed, like it's got math in it, like it's all correct math, But I think a lot of the problem is that there's a series of people in the Bay Area, largely it seems, who are very sort of technically talented in trying to solve all of these like real problems that emerge when you refuse any type of centralization whatsoever. So like from a pure intellectual perspective, what an amazing type of thing to be able to do, to say that we can even make progress at all if literally I only know you by your public keys that aren't tied to any real identity, right? But then I think there's a series of like a larger set of people who are sort of well-intentioned but who are not distributed systems experts and also refuse to learn about it, right? It's the second part that's more disturbing. Who think like I've had like people who are like I would consider smart in most ways. Well, up until they said this next thing, where they're like, we never had distributed databases before the blockchain. What? You should be disbarred from life. You should just be disqualified from any good thing in the future, right? Because like if you talk to like IBM, what do you think these people were doing? For 10, 20 years, making distributed databases, And then you also see, too, and then this set of people I actually feel bad for, and I try to help them. People who have legitimate use cases that are being sort of made difficult by the current world. So, for example, remittances. So let's say that you come from a country that's not stable economically, and then you want to go to another country and then send money back. Now, depending on like the exchange rates of the fiat currency and stuff like that, if there's hyperinflation and the blah blah blah, like that's a difficult problem. So people say, oh, well, maybe like cryptocurrencies can help us out here. It's a way to do remittances in a way that isn't sort of subject to the whims of some central government, right? That's a very valuable use case. Another use case that like the American government's very concerned about too, disaster relief. So like there's a bunch of people in America who are unbanked. They don't have a bank account, right? And yet, you need a bank account to do many things. For example, like if a hurricane comes through and the government wants to distribute aid, what do? Like right now, in many cases, they ship debit cards. And that is just fraud town. I mean, it's just a terrible idea, but it's the best they have. So maybe we could use crypto somehow to help unbanked people, right? So like those two use cases, for example, are very compelling. But do the current blockchain system provide it? No, I don't think that they do. And so what I think ends up happening is that there are a lot of people who like this idea of decentralization intuitively because that just seems more stable. It seems less capable of being controlled by a single power. But then if you look in practice, like you were mentioning, right, you see that, for example, in proof of work systems, what does that mean? Basically, you get 1 vote per CPU cycle, right? So guess who has a lot of CPU cycle? Gummit. Gummit got a lot of CPU cycles. Guess who else has a lot of CPU? Rich people. So on and so forth. So why is that sort of a problem? Well, it's a problem because if you think about what that means, right? And this is actually like very deep, and so that's why I'm leaning forward. I'm about to tell you something that's very important. What that means is that power in the fiat world translates to power in the crypto world.
That's right.
You see? And the reason why that's important is because that sort of blows up all these assumptions about, oh, we're all going to go to the crypto world and then somehow like it's all going to be fun and games because, one person, one vote. No, you can't have one person, one vote because you refuse to use real identities that are tied to any credentialing authority. So you end up using a proxy for identity, which like, for example, in the case of Bitcoin is access to CPU power, but access to CPU power is a proxy for power in the fiat world. So then you say, oh, James, you're just, I get it. You just want to be sarcastic. But let me tell you something. This proof of stake stuff, it's much better. No, dingus, listen up, right? It's like what happens, not you, just the world, So like, what's that? So basically proof of stake systems, roughly speaking, they say your ability to vote is proportional to how many tokens you have, right? Oops. Like what is token ownership proportional to? Fiat power. So it's just a big mess.
There we are again. Who had one back over here? Max.
Yeah, I had a question for you. It's kind of a moonshot, but as you were talking about, not trusting the CPU and Intel being this, like there's Sony, I think, recently came up with like a chip for their camera that's going to like digitally sign the picture so it's not tampered with and stuff like this. And I, as a tech person, I find this cool. That's like good application of cryptography and not cryptocurrency. But I feel like there's a gap with the general education of people, right? Like email is like PGP since like decades and nobody uses that. All we were, as tech people, were able to teach people like, if there's a little like lock, it's because HTTPS, you need to look for that little lock, right? How do you think, like, is there a way to get people to understand this? Like not just the people that could be in this room, but like the general population to really understand like the value of cryptography and like I know it's a vague question, but like what are your thoughts on this? Because we can all work towards this and build stuff around this and make sure that Intel is signing the right things, but how does that translate to everybody that are actually going to be the users of that?
Yeah, another great question. I mean, I think this sort of ties back to this idea of like who are going to be the people in computer science who evangelize and explain? Like who's going to be the Stephen Hawking for computer science and explain this stuff? And like at least for me, like the thing that I think is helpful, like when I'm teaching stuff, for example, is coming up with metaphors that are concrete and sometimes being okay with not like explaining the nitty-gritty of stuff, So like with signatures, for example, like that's a really foundational technique, And so like you don't need to understand, modular arithmetic or things like that to understand, the two critical parts of signatures, which is that they provide attribution and integrity. They tell you that somebody said something, and furthermore, that thing that they said hasn't been changed. And so you can explain that just using pure human language, right? And I think that there's a bunch of other techniques, just encryption, stuff like that can also be explained in sort of plain English. Like Signal does a relatively good job of explaining this, end-to-end encryption and what that means and who can and can't see things. So I think to me, one of the big sort of impedance mismatches in terms of education is I think, sometimes I read New York Times articles about popular science, and I feel bad for those reporters because it's tough to explain this stuff, and they always walk this tightrope between I want you to sort of get an intuition for the math versus just here's what it looks like sort of at the hand wavy level, and I think the industry is still trying to find that level, inside. But to me I think it's cool that Signal's starting to get more adoption. I think it's cool that things like Tor are starting to get more adoption. But I think that another challenge, that Tor points out, for example, is that if your security tool is slow, people aren't going to use it. And if you try to do anything through Tor, that's a generational project. I want to load CNN that your children's children may get to enjoy when that page comes back. Now you're getting something out of it, obviously, but that's to me another sort of key thing when we think about security too. Usability and performance. Because a lot of times, and I see this in research too. I mean, I'm a researcher, so I'm talking about my own tribe here. But a lot of times, as researchers, we want to be purists. We want to say, just imagine a world where our tinfoil hats are made of tinfoil hats, and we're willing to wait indefinite amounts of time because we're consuming the spice from Arrakis or whatever. And so, that sounds great for us. That's a cool intro for a paper. It's not going to make it in production. So I think that's another issue too, where we want to educate people about what these basic terms are, and keep in mind that sometimes good enough is better than perfect in terms of what's actually going to get deployed and used by people.
We have time for one more question. Yakov?
James. Okay, so I just want to hear a few more. This is all good. I've got some topics to discuss later, but just one more topic, metaverse. Have you got a
now you're just
5 minutes
chumming the water.
download?
Exactly. My eyes roll in the back of my head. Start speaking in tones.
Tinfoil hat back.
Yeah, exactly. Metaverse. Yeah, once again, the TLDR, it's probably going to be a bad idea. I mean, the thing about the metaverse, and this is not an original point that I've made, but all of the sci-fi novels and stuff that came up with this idea of the metaverse, these are all dystopian nightmares. None of the inspirational literature for the metaverse is ever a children's story. It's never, look at Tim and Sally strolling through the metaverse. No, their organs have been taken out. They're being used as, human robots. So it's never a good idea. I think so there's sort of two things we could talk about. One is sort of Facebook's specific motivations for going to the metaverse. Then there's just sort of the metaverse in general. As for the first thing, they're just trying to distract because they are just getting sued all the time. They're looking for some way to make people forget about their most recent set of failures. So that's my take on the Facebook version of the metaverse. And if you look at it technologically, yeah, great. A gentleman and a scholar, as I already knew. So then, with respect to sort of this general idea of the metaverse, well, I think it's back to sort of something that we were talking about before. What problem is it solving? We've had sort of metaverses Second Life, for example, and what ends up happening is that I think not because the technology wasn't immersive enough, but just because what do you do? You can hang out with people, but then it's kind of awkward. If you have any network lag, then it's just weird because you're phasing through walls and stuff like that. And it's if I wanted to feel awkward with someone, I just go talk to someone in real life. Why would I want to go online and add another layer of uncomfortableness? So, I think that I always hear in theory there are these advantages you can bring together people from different but we already have, internet and Reddit, stuff like this, do those kind of things. So from my perspective, it's just going to be, to first approximation, social media, version 8.0. I don't see a killer app for the metaverse that we couldn't also say, well, can't you do that on, Instagram or Facebook or things like that? So, much like crypto, much like, generative language models, for example, I think there's some cool technologies there that I don't quite see being actually useful. I do think that augmented reality may be something. And like Facebook, depending on like which video you look at, they sometimes conflate these two things. I think augmented reality could be great for healthcare situations, for any number of things, just sort of alerting you of dangers in your environment. So that could be cool. It's like that's a technology, metaverse-wise, that I'm the most excited about.
Well, we're going to have to call it right there. James, I really want to thank you for this dull, uninspiring conversation. And listen.
You're welcome.
I nominate you to be the computer scientist who explains and persuades and makes these concepts accessible for more people. So keep at it, man, and we're going to have you back. By the way, you're going to join us for dinner tonight, right? So people like Yakov and others can buttonhole you. Great. Watch out for Yakov. It's coming. No, but really, this was a lot of fun. Really, really awesome, James. Thank you again. Before we adjourn, I have 3 housekeeping items I need to share. The first, maybe you, like me, were confused. Am I wearing my Western gear tonight's dinner, or tomorrow's dinner? It's tomorrow. So just keep on rocking your Superset T-shirts for dinner tonight. No need for a costume change there. The reception and dinner is at 6 o'clock, and it is a 9-minute walk from where we're at, right? Am I getting that right? And we all have the address in our calendar invites. And now, everybody, we're going to move these chairs off the stage or to the side, and everybody in this room is going to come to the front, and we're going to take a big group photo together. Okay? So there'll be a little chaos and then a photo. Thank you again, James.
Thank you.